test for the convergence of the series summation n factorial whole square x to the power of 2n by 2n factorial where x is greater than 0. You observe in the given series they are given factorial term and it contain nth term. So this is we can consider as a un. Since x is greater than 0 and you know that n factorial is greater than 0, 2n factorial is also greater than 0. So both numerator and denominator greater than 0. Hence it is a positive. So the given series is a series of positive terms for every value of n. Now the series is containing factorial. So we have to go for ratio test. When the series is containing factorial, which method is the best method is here ratio test is the best method. So in the ratio test we need to find un by un plus 1. So n plus 1, un plus 1 I want. In place of n, I have to substitute n plus 1. It is not like repeated series form. This is does not containing the previous terms. So directly you put n is equal to n plus 1. So n plus 1 factorial whole square x to the power of 2 into n plus 1. 2 times of n plus 1 by 2 times of n plus 1 factorial. If you split this one, then it will become, and you can write as n plus 1 factorial whole square x to the power of 2n plus 2 by 2n plus 2 factorial. Now I want a un by un plus 1. In the ratio test now we are doing now. So that is un by un plus 1 is numerator un and denominator un plus 1. In the denominator, see, you have to simplify. This means you have to cancel the common terms. For the term n plus 1 factorial you can write as n into n plus 1 into n factorial. N plus 1 into n factorial it will becomes n plus 1 whole square into n factorial whole square. X to the power of 2n plus 2 you can write as x power 2n into remaining x square. This 2n plus 2 I can split up to 2n factorial. So for the 2n plus 2 factorial you can write as 2n plus 2 into 2n plus 1 into 2n factorial. What purpose we are done like this? You understood, na? Because to eliminate common terms, right? Now n factorial getting cancelled. This n factorial whole square, n factorial whole square cancel. X to the power of 2n, x power 2n cancel. 2n factorial, 2n factorial cancel. And the remaining terms are 1 by we need to write. 1 by, instead of 1 by I am writing as a reciprocal. So the denominator will become in the numerator. That is 2n plus 2 into 2n plus 1 by n plus 1 whole square into this is 1 by x square. Now multiply. Here you will have 2n into 2n 4n square plus 2n into 1 2n plus 4n, that is becomes 6n plus 2 into 1 is 2 divided by n plus 1 whole square is n square plus 2n plus 1 into 1 by n square. This is un by un plus 1. Now we have to apply limit on both sides. Simply, can you guess what you will get the limit if you are applied as interest infinite? N square by n square. So in the numerator and denominator have n to the power of same. Therefore you will get the coefficients of n square in the numerator and denominator as limit. So that is 4 by 1 into 1 by x square. That is 4 by x square you will get. Okay, na? So 4 by x square is limit. Limit we have 4 by x square. Do you know what about x value? Don't know. Generally here they are given, in the problem they are given x is a positive. X positive means x may be less than 4, x may be greater than 4. X square may be less than 4, x square may be greater than 4, or else x square may be 4. So the chances what we have means 4 by x square may be greater than 1, less than 1, is equal to 1. If 4 by x square is greater than 1, you can say the series is convergent. If 4 by x square less than 1, the series is divergent. Let 4 by x square is equal to 1. That implies x square value will become 4. Now we have to substitute this x square value in the given series. So we have n factorial whole square by 2n factorial into x to the power of 2n. X square is what? 4. So 4 to the power of n you have. Now you observe this is our new series. In the new series, the series is containing what? Again factorial. So go for ratio test. In the ratio test, we have to do again un by un plus 1. Instead of doing un by un plus 1, directly you substitute x square value is equal to 4 in the series. Here only you have to substitute. Here limit, in the limit. So 4 by 4 is 1 you are getting. So limit is here, finally you are getting 1. You see, this is x square is equal to 4. If you substitute, this will become 1 by 4. The quotient is 4, n square quotient is 4. So limit if you are applied, then you will have 4 by 4. 4 by 4 is 1. Again you have limit is what? 1. Therefore ratio test is fails. Here you have ratio test is fails. Is L value is containing x by e or e by x? You check it. L is what here? L is what we have? 4 by x square. It does not contain e. So go for Raabe's test. If it is containing 4e by x square or else 4 by x square into e, like if it is containing e term, you have to go for logarithmic test. But it is does not containing e, so you have to go for Raabe's test. In the Raabe's test, we need to find n into un by un plus 1 minus 1 limit for this. So first of all, n into un by un plus 1, what you have? I am written minus 1. Now what is the LCM for this? 4n square plus 8n plus 4. Now numerator minus denominator you will have if you take an LCM. Now 4n square plus 4n square plus 4n square minus 4n square cancel. 6n minus 8n, so minus 2n. 2 minus 4 is minus 2. Now this is minus 2n square minus 2n by 4n square plus 8n plus 4. Now limit n tends to infinite, n into un by un plus 1 minus 1 is equal to limit n tends to infinite. This one, just we are taking limit on both sides. Again you observe numerator is highest degree is n square, highest term is n square, denominator highest term is n square only. So you will get as n tends to infinite limit is minus 2 by 4. Yes or no? The coefficients only na? Minus 2 by 4. Minus 2 by 4 is minus 1 by 2, which is again less than 1. That is L is equal to minus 1 by 2 less than 1. When L is equal to 1 by 2 minus L is equal to minus 1 by 2 less than 1, that is limit is less than 1. Which method we are doing? N into un by un plus 1 minus 1 limit na. So this is a Raabe's test. In the Raabe's test, if L is less than 1, what we can say? Test is divergent. So what we can say from this? Finally, summation un is convergent by 4 by x square greater than 1. For less than 1, divergent. Is equal to 1 is also divergent. Hence what we can say? For 4 by x square greater than 1 convergent to 4 by x square less than or is equal to 1 divergent. This is the Raabe's test.